Before calculators were cheap and plentiful, people would use mathematical tables, lists of numbers showing the results of calculation with varying arguments, to simplify and drastically speed up computation. Tables of logarithms and trigonometric functions were common in math and science textbooks. Specialized tables were published for applications such as astronomy, celestial navigation and statistics. A simple example: to compute the sine function of 75 degrees 9 minutes 50 seconds using a table of trigonometric functions such as the Bernoulli table from 1619 illustrated here, one might simply round up to 75 degrees 10 minutes and then find the 10-minute entry on the 75-degree page shown above right, which is 0.9666746. However, this answer is only accurate to 4 decimal places. If one wanted greater accuracy, one could interpolate linearly as follows. For the Bernoulli table, sin equals 0.9666001. The difference between these values is 0.000745. Since there are 60 seconds in a minute of arc, we multiply the difference by 50/60 to get a correction of *0.000745 approximately equals 0.000621, and then add the correction to sin to get sin approximately equals sin plus 0.000621 equals 0.9666001 plus 0.000621 equals 0.9666622. A modern calculator gives sin equals 0.96666219991. So our interpolated answer is accurate to the 7-digit precision of the Bernoulli table. For tables with greater precision, higher-order interpolation may be needed to get full accuracy. In the era before electronic computers, interpolating table data in this manner was the only practical way to get high-accuracy values of mathematical functions needed for applications such as navigation, astronomy, and surveying. To understand the importance of accuracy in applications like navigation, note that at sea level 1 minute of arc along the Earth's equator, or a meridian, equals approximately 1 nautical mile. History and news. The first tables of trigonometric functions known to be made were by Hipparchus and Menelaus, but both have been lost. Along with the surviving table of Ptolemy, they were all tables of chords and not of half-chords, i.e. the sine function. The table produced by the Indian mathematician Aryabhata is considered the first sine table ever constructed. Aryabhata's table remained the standard sine table of ancient India. There were continuous attempts to improve the accuracy of this table, culminating in the discovery of the power series expansions of the sine and cosine functions by Madhava of Sangamagrama, and the tabulation of a sine table by Madhava with values accurate to 7 or 8 decimal places. Tables of common logarithms were used until the invention of computers and electronic calculators to do rapid multiplications, divisions, and exponentiations, including the extraction of nth roots. Mechanical special-purpose computers known as difference engines were proposed in the 19th century to tabulate polynomial approximations of logarithmic functions, i.e. to compute large logarithmic tables. This was motivated mainly by errors in logarithmic tables made by the human computers of the time. Early digital computers were developed during World War II, in part to produce specialized mathematical tables for aiming artillery. From 1972 onwards, with the launch and growing use of scientific calculators, most mathematical tables went out of use. One of the last major efforts to construct such tables was the Mathematical Tables project that was started in 1938 as a project of the World works progress administration, employing 450 out-of-work clerks to tabulate higher mathematical functions, and lasted through World War II. Tables of special functions are still used, for example, the use of tables of values of the cumulative distribution function of the normal distribution, so-called standard normal tables, remains commonplace today, especially in schools. Creating tables stored in random access memory is a common code optimization technique in computer programming, where the use of such tables speeds up calculations in those cases where a table lookup is faster than the corresponding calculations. In essence, one trades computing speed for the computer memory space required to store the tables. Tables of logarithms. Tables containing common logarithms were extensively used in computations prior to the advent of computers and calculators because logarithms convert problems of multiplication and division into much easier addition and subtraction problems. Base 10 logarithms have an additional property that is unique and useful. The common logarithm of numbers greater than 1 all have the same fractional part, known as the mantissa. Tables of common logarithms typically included only the mantisses. The integer part of the logarithm, known as the characteristic, could easily be determined by counting digits in the original number. The fractional part of the common logarithm of numbers greater than 0 but less than 1 is just 1 minus the mantissa of the same number, with the decimal point shifted to the right of the first non-zero digit. But same mantissa could be used for numbers less than 1 by offsetting the characteristic. Thus, a single table of common logarithms can be used for the entire range of positive decimal numbers. See common logarithm for details on the use of characteristics and mantisses. History. Michael Stifel published Arithmetica Integra in Nuremberg in 1544, which contains a table of integers and powers of 2 that has been considered an early version of a logarithmic table. The method of logarithms was publicly propounded by John Napier in 1614 in a book entitled Mirifici Logarithmorum Canonized Descriptio. The book contained 57 pages of explanatory matter and 90 pages of tables related to natural logarithms. The English mathematician Henry Briggs visited Napier in 1615 and proposed a rescaling of Napier's logarithms to form what is now known as the commoner base 10 logarithms. Napier delegated to Briggs the computation of a revised table, and they later published in 1617 Logarithmorum Chilias Prima, which gave a brief account of logarithms and a table for the first 1,000 integers calculated to the 14th decimal place. The computational advance available via common logarithms, the converse of part numbers or exponential notation, was such that it made calculations by hand much quicker.